So now everybody who wants to have their camera on has to turn them on back on again. And yeah.
Never seen it do that before. It doesn't do that in our teams. Okay, so all the microphones and cameras have been turned off, and then we have to turn them back on if we want them on. Interesting. It's now. Okay, and then I've got to share my screen again.
Yeah.
So, shall I start? Okay, so welcome to the launch of the Energy Fault Detector Challenge, together with Fraunhofer IEE. So we have Christian and Florian here today. Do you two want to introduce yourselves now, or do you want to do it when your part comes?
We can also do it when our part comes, since we talk about the Fraunhofer IEE nevertheless. So yeah, we will introduce ourselves then. Maybe there are also a few people who join until then.
Yeah. Okay. We'll do that then. So I'll do an introduction to WeDoWind for those of you who don't know about it. And then Christian and Florian will take over and talk about Fraunhofer IEE and also this challenge. And after that, we have a small Mentimeter questionnaire, just one question, or 2 questions, I think. And then we have time for any questions. But because we're quite a small group today, if you have any questions, just speak or write in the chat. I can see your faces anyway. I can see the chat. So feel free to just ask as we go along. So my name's Sarah Barber. I'm from the Eastern Switzerland University of Applied Sciences, and I run this WeDoWind project. So my research has got quite a lot to do with digitalization, which means creating value from data. We also have a different research project on flow modeling in the mountains because of Switzerland, and also rotor aerodynamics. So, but this WeDoWind thing belongs strongly to the digitalization part. And so what is WeDoWind? So the idea is to exploit the full value of data in the wind energy sector. We want an industry where data and knowledge flow freely. So we think by sharing open data code and best practices, we can accelerate innovation. So on WeDoWind, we want to develop community-driven standards and tools. And the idea is you might have heard the typical data scientist spends 80% of their time cleaning data and only 20% of it creating value. So our idea is that we kind of reverse that and we say, well, if we share more, then we can spend more like 80% of the time creating value. So on WeDoWind, we've had some challenges run before. So the first one we did a few years ago was with EDP, who we developed some fault detection methods, and we actually, for some specific cases, we could compare the new methods to EDP's existing method, and we actually had an estimation for the cost it saved them. We also had a challenge with a Swiss company called RTDT. We looked at structural health monitoring of acceleration data and provided them with some new code for their analytics. Where some of you might know, there's a challenge running at the moment with RES. So it's about power curve prediction. So they're getting access to all the codes and the insights being developed as part of that challenge. And then we have another space run by Nuveen, where we have several challenges that we've run. We've just launched one last week about static yaw offset prediction. So we actually got some ground truth data from the Swiss wind turbine in Switzerland, and we're trying to compare different codes there. So WeDoWind we see as a hub or a community. At the moment, we have somewhere between 400 and 500 people from all over the sector sharing data and expertise. It was founded at my university, which we call OST for short. and it's about being inclusive. So anyone can take part as long as you have an internet connection and a computer. You don't need to pay anything. We want to include people from all over the world. And we've built this thing called the WeDoData Blueprint, which is like a framework for open innovation. And the idea is that the people who are creating these data models and ontologies to describe the data, they want to apply that to real data sets, and these data sets then get published for the challenges. And then the people taking part in the challenges want to get access to these data descriptions to make their analytics more efficient. So all these different people doing these different things within the ecosystem are supposed to get synergies from each other and work with each other. So we want to unite diverse participation in a common forum. I really like the challenges because I really like the fact that anyone who doesn't have any experience in data and analytics or wind energy or anything can come and take part. And sometimes those people even have better ideas or have at the end come up with better solutions than people with lots of experience in wind energy. So I think it's a really nice mix, really nice to get this mix of people. So sort of the three main things we do, we connect people with data, code, also lecture material, with information models, that's models that describe the data, with best practices and guidelines for using and publishing code and data. But then we also provide opportunities for working together. So one part is to develop code and reference method. That's the idea of these challenges. But there's also this idea of co-creating information models and working on best practices together. And the final thing is just, the whole point is to get connected with people. So you can see who else is a member, you can chat to them, you can see what else is going on. You can set up new collaborations. We even have a job portal where you can look to see what jobs are on offer, and you can make people aware if you're looking for a job. So yeah, we have these 4 separate communities: information modeling, open data and code community, collaborative problem-solving community, and the data and code users community. So the challenges are all inside this collaborative problem-solving community. And inside these communities, we have members doing all these things, so sharing and aligning data, defining best practices, running open challenges, and accessing training and jobs. This is what the blueprint looks like. So it's basically showing how these 4 communities here in green are connected to each other. So we have people developing information models who are publishing the results on it publicly, and these publications get then used to describe the data. We don't actually have a wind energy open data portal yet, but we are working on it. And then the idea is that the people working in this group, they develop guidelines for making this data and code more accessible and usable. And then the people working in these challenge communities are using this data and the code, and they're iteratively improving the code. So you'll see in this challenge, we have an open code available, and the idea would be then through the challenge, the community helps to actually make updates and make improvements to this open code. And then we have a data users community, which are basically people getting together talking about more like data engineering stuff, sort of general issues with dealing with data. With the communication platform is the WeDoWind platform, so that's basically where all the people come together. And we're also currently working on a data science platform where we can run our challenges called Renku. This challenge today is not using Renku, but some other challenges we're running does. So I can tell you more about that if you're interested. Then we have the jobs portal on here as well. So just to summarize, the information modeling community is developing community-developed semantic artifacts or ontologies. The open data and code community is developing guidelines for publishing data and code. The data users community, the collaborative problem-solving community is working on challenges and developing solutions and reference methods together. Then the data users community is developing also guidelines for using data. So I said before, this communication platform was kind of the thing that holds all these people out here together. So we use this software. We use actually a commercial software called Mighty Networks, and the platform is kind of split into these 4 different communities, which I mentioned already. You can access different data, tools, events, and people. And then there's different working groups. So some of them are public, some of them are private. Some working groups you can actually, inside the platform, you can coordinate the work. So you can actually look at the activities and chat with people and look to see what's going on. Some of the spaces are just links to other platforms where people already have their working group working somewhere else. And then the portals, so we use this thing called a techno portal for ontology publishing, and we're currently working on a cataloging system for cataloging existing wind energy data and code. So probably all of you who got to this event probably got there because you came on the platform, I'm guessing. So you probably all saw that if you go to this website here, you see this, and then you can join. Other ways you can get started on WeDoWind, you can donate. There's a link also on the main page. You can start a discussion. So on WeDoWind, there's this thing called general discussion where you can start a discussion about anything related to data. In the feed of each space, you'll see a discussion option for things related to individual topics. You can join a challenge like this one and attend the next meeting like you're all doing now. But you can also join an information modeling group or a data users group or an open data group and attend meetings. You can create new challenges or new working groups, but at the moment you have to contact me to do that. And you can also sponsor WeDoWind. You have to contact me for that as well. So any basic questions about WeDoWind before I pass over to the Fraunhofer colleagues? Just a note to the people who've come in, because we're recording, I think your camera gets automatically turned off. So if you want us to see your smiling faces, I think you have to turn your camera back on, which is obviously optional. So Christian, do you want to take over then if no one's got any questions?
Yeah, I can do that. So yeah, I will now introduce the Fraunhofer IAE and the Energy Fault Detector challenge, which we want to do in collaboration with WeDoWind. Maybe I share my own screen just so I have control over the clicking.
Go for it.
Yeah, I hope you can see it all. Okay. And yeah, today my colleague Florian and I are taking part in this meeting to explain the Energy Fault Detector challenge. Maybe for introducing us, we are researchers on the Fraunhofer IAE, which is a German research institute which focuses on application-oriented research in the for energy economics and energy system technology. This covers research in renewable energies, for example, and and for the power grid, for example. And we are Florian and I are located in a team within the energy informatics department of the Fraunhofer IAE. Our team is called FDI, which stands for Automated Energy Fault Detection and Identification. And I have the background to being a mathematician and working on fault detection algorithms within this team. And now I give Florian also time to talk a few sentences about it.
Yeah, thank you, Christian. My name is Florian Rewert. I'm also in the same group as Christian told. And my background is in electrical engineering. And from my side, I only want to add we have multiple fields at our institute. Christian said something about these 7 here on the screen. And if someone has questions to other parts, we can also bring in contact with other people there. But our focus is on renewable energies and detecting faults in them. And yeah, maybe when I can give back to Christian, who will explain the challenge itself.
Okay, thank you, Florian, for the presentation. Yeah, exactly. That's it for the Fraunhofer IEE. Yeah, as Florian said, if you have more questions on that, we have the Q&A session later, and you can contact us regarding that. Yeah, within our team, within the automated energy fault detection and identification, we obviously care about detecting faults in renewable energies. And one big part of that is detecting faults in wind turbines, because with wind farms, we have the problem. We have a steadily increasing number of wind turbines. But the number of technical staff which monitors the wind turbines and and operates them does not increase in the same manner. So we actually have some problems with wind turbines which have downtimes due to faults. So in those downtimes, they cannot produce any electricity, and so thus they cost a lot of money. And by detecting faults early, we can optimize the wind farm operations significantly. And for that, we want to detect them in an automated manner. So we want to detect anomalies that lead up to the fault of the turbine itself, and if we detect them early, we can notify the operator, and the operator can make plans in advance and lower its maintenance costs, and this leads to a higher operational efficiency of the wind farms themselves. And there are already a lot of publications in this field. So there are a lot of research has been done to create automated fault detection algorithms for wind turbines. But the vast majority of those studies focuses on creating a new fault detection algorithm and applying it in a case study where they use data which they were allowed to use for only their research purposes, and which are not publicly available after they have made their publication. So it is a real challenge to meaningfully compare results of different research publications, and there's no standardized benchmark on for the wind for anomaly detection methods for wind turbines. And what we did to try to solve that is we published a comparison framework, or at least a score which can compare two different fault detection algorithms for wind turbine monitoring based on the most relevant features of those models for practical reasons. And additionally to the CARE score, which we named this measure, we also made a public data set which has detailed labels about error information and normal behavior of wind turbines. It contains a balanced amount of examples for both possibilities. It has a lot of data, especially in comparison to other public available data sets, which oftentimes lack depth, and also has high quality. The data set is available on Zenodo, and it consists of 10-minute resolution sensor time series of wind turbines. We have 3 different wind farms inside the data set, and a lot of wind turbines from the different wind farms. And because there are different wind farms, they have some data sets have high dimensionality, so 270 features, for example, and other wind turbines do not have as many features. there are, in addition to the sensor data for each turbine, also extensive labels for the operating mode. This means we have some time series that explains in which mode the turbine was according to the operator at this timestamp. So if it was thought to be a normal production mode, or if it is maybe currently shut down due to maintenance or due to an error. And then we have also error information, which we put together in post analysis by looking at the service reports and analyzing interesting timeframes together with the wind farm operators, which we work with in a research project. So we have the sensor data and the additional label information inside the data set, and we combine those then to 95 event data sets, where we have 50 examples for normal behavior of wind turbines and 45 examples of anomaly events which lead to a fault. You can view this like the following. Here we have for each wind turbine those sensor time series for a lot of different features, and an anomaly data set is then consists of 1 year of training data for all those sensor measurements, and those training data are mostly of normal operating status. So those can be used to train some kind of model, which then can predict the prediction data. And for an anomaly event data set, within this prediction data, we have some time frame where we can detect anomalies which lead up to a fault that leads to downtime of the wind turbine. And for a normal event data set, we also have 1 year of training data and a prediction data where only normal behavior is occurring, and we just evaluate some time frame from this prediction data. If you want to find more detailed information, you can look in the WeDoWind on the WeDoWind website in the energy fault detector challenge space. There we link to the original Zenodo repository where the data is located, and we also published a paper explaining the CARE score and explaining the data set in detail. You can find both there. That's it for the data set. Now the challenge goal is that we want to compare different fault detection methods based on this sensor data from the SCADA system of the wind turbines. And we have basically this one overall aim, and this divides into 3 sub-aims. First of all, we of course want to detect all actionable anomalies. So we want to detect all anomalies that lead up to faults. Second, it is very important to not raise false alarms during normal operation. This is why we have those normal operation examples in the dataset. And we also want to detect the real anomalies as soon as possible, so that there is as much time as possible to plan maintenance in a real scenario. So those are the 3 aims of this challenge, and this is all this is all included in the CARE score, which we designed to cover those aspects. So the CARE score has 4 different parts, which are the coverage. It evaluates the point-wise anomaly detection capability. So how much of an anomaly event can I really detect? Then the accuracy aspect, which evaluates how much of normal events do I really classify as normal, and how many false alarms do I possibly have? And then we have the reliability measurement, which looks at the events themselves. So not a point-wise measure, but it views each event as 1 point, and evaluates the classification rate on those in this dimension. And then we have also the earliness aspect, which just weights how early were you able to detect a fault that occurred. And all this is put together into one score, which then represents how good the model is in covering all those all the three aspects at once. And that's what we will use to evaluate models. And how we evaluate models is if we use a Kaggle data challenge, where there is a private and a public leaderboard, and we divided the data set that I presented earlier with its 95 events into a public group and a private group, where we made sure that there is each time a balanced amount of normal and anomaly events inside, and we also ignored five data sets so that it cannot be easily reconstructed which event is public and which event is private. So an approach would be evaluated by predicting the entire data set and uploading the prediction for that. And then we show the public leaderboard score for the public portion of the data set, and the private leaderboard score will be used at the end of the challenge to compare the models and rank the submissions then. So the public score will be visible at all times, and the private score will be just visible after the challenge has concluded. So that's for the evaluation. And of course, we hope that nobody dares to cheat, because the data set is of course entirely public. So it would be maybe not that difficult to reconstruct the optimal prediction by not using a machine learning model, but just by trying to cheat the system. But we really do not want this to happen. So we made this public-private split with the 5 ignored ones, and we additionally hope that no one has those ideas in mind. Also, if you want to take part in the challenge and you want to submit here and be ranked in the private leaderboard later, you will also have to present your approach in the final event of challenge. I will explain it in a little bit. But those are measurements against cheating and for more exchange on how you actually did it. So a baseline for the evaluation can be the energy fault detector framework, which we published open source during this year. So the energy fault detector is a Python package, and it contains different different parts. One is the baseline, which is just a data preprocessing pipeline that prepares data that can be processed by an autoencoder in a threshold analysis module, so that anomalies can be detected with this pipeline. Then we have also a root cause analysis module inside the framework, which is maybe not that relevant for this challenge, but it is still contained there. And we have also very relevant for this challenge implementations of the CAR score and handling classes for the data set that we provide, because this makes it much easier to load the data set and to analyze it, because all the events just get loaded, and there will be examples that easily show how to apply your own model to the data. This framework is openly available on GitHub, and you can use it as a base for your own experiments, or you can develop your own solution independently. So there will be a solution template, which will be which you can find on Kaggle in form of a Jupyter notebook. This solution template uses this energy fault detector framework as a basis. And as I said, you can also completely independently create your own solution and just submit the prediction. But yeah, you can also start with the Jupyter notebook, and you can even branch off our repository and develop your code in there and make suggestions for improvements of our framework. Yeah, additional information that go further than the solution template can also be found in our repository with the Care to Compare notebook, which can show you examples how to customize your evaluation and how to have a more detailed look inside the data set for optimizing your models. So how can your prediction be submitted? It's kind of a little bit finicky here because of the Kaggle restrictions that we always have to submit one data frame or one CSV file. And because we have an event-based data set, we require one CSV file which contains a column event ID, where the IDs of the 95 events present in the data set is one column. And then in the prediction column, we have a list of booleans that is as long as the prediction time frame of the corresponding event. And true just means that an anomaly was detected, and false means there's no anomaly detected. And then we also require a column prediction index, where the index ID of the timestamp or the timestamp itself should be provided. You can find an example for the submission file on Kaggle, which we publish directly after this kickoff. And by submitting such CSV files, you can submit up to 10 times daily and view your public score afterwards. So that's it for the submitting part. And yeah, how can you now participate? In short, first you will have to register in the energy fault detector space on WeDoWind. There is an Excel file where you can just enter your name and you get a participant ID. You only need to do this once per team if you intend to work in a team. And you can attend the kickoff meeting that you currently are attending. Or view the recording that we will publish afterwards. And there will also be two interim webinars on the 3rd of November and the 20th of November, each at 16 o'clock. There you can ask, there we have time for a more extensive Q&A session and for getting into contact with each other about the challenge. So kind of the Q&A session at the end of this kickoff, but longer and during the challenge. After that, there will be the final event, or there will be the deadline at the 28th of November, where the Kaggle challenge concludes, and after that you will no longer be able to submit. And as I said before, for submitting, you can use the solution template or fork from the energy fault detector repository to develop your code. And after the final deadline, we present the solutions in the final webinar on the 5th of December. And there you will also have to present your own approach if you want to be considered in the final evaluation. So you will be provided a link where you can upload a PDF of your slides where you present your approach and how you solve the challenge. And your presentation will be held in this final webinar on the 5th of December. So, and then also one more requirement is to fill out the participant survey, which will be taking place at the end of this kickoff meeting. This will be used to evaluate the WeDoWind project and give us a lot of insights. So that's it for participating. Now the question is, why should you take part in this challenge? First reason is working with real data can give you real experience with all the real world problems that are inside this data set. Although we have these luxurious situation that we have labeled event timeframes, and those event timeframes might not be perfect, and also the operation status which is provided can be difficult to deal with. There are really high dimensional examples in this data set which make it really difficult to achieve a high CAS score. So this is one reason. It's a real challenge. And you can also contribute to our open source framework and become a part of our open source community with the energy fault detector by suggesting new improvements and advancing our framework there. In fact, already someone is working on a real big pull request for our energy fault detector. I was just wondering, is the person maybe here today? Because that's really extensive work that has already been done. So we are very fascinated by that, and grateful for that. So our community is steadily growing there, and you can be a part of it too. And you can also by taking part in the Kaggle challenge, be a part of. You can. Sorry, I just lost my words there. You can take part in the Kaggle challenge and compare yourself with others on the leaderboard, and show your skills and publish them so that it is reproducible. And you can also engage with us on Fraunhofer IEE on our research topics alongside this challenge. And this can also help your visibility and your career growth. So that's just some reasons for why you might want to take part in this challenge. And the next step would then be to enter your name in the Excel sheet and get a participant ID. And then after that, we can start the challenge. And that's it for the current challenge overview. I would say we can then go to the Mentimeter questions, and then afterward we can do the Q&A. Sorry. Then I would give back to you, Sarah.
Yeah, you can just move the slide on one. You don't need to. Actually, no, I'll take over again. So because I'll show the Mentimeter results then. So you can scan the Mentimeter QR code, or I put the link in the chat. And just got a couple of questions for you all. Let me get the Mentimeter up. So you should be able to see the first question. So I can see that 7 people have got it. If you need the QR code again, let me know, and I'll move it back on. Oh, nobody's responded yet. So 8 people.
Yes, excuse me, I need the QR code.
Okay, but 8 people. I will do, but apart from okay.
Thank
There's the QR code, yeah. But I can see that 8 people have scanned the code or clicked on the link. I guess you're just reading it, so I'll give you a bit.
Sorry.
No, it's fine. I can keep that on the screen for.
Okay, thank you.
So I'm most interested in learning from others, accessing real data, meeting people, sharing ideas, writing a collaborative paper, working in a team, winning a prize. See, winning a prize always comes right down at the bottom. I originally thought it was going to be a top motivator, but nobody seems to care about winning a prize. If anybody wants a participant certificate, we usually give them out anyway. It's not really a prize, but you can use it in your CV and stuff. Winning a prize is right at the bottom there. I can see that half the people are still thinking. I'll give you a little bit more time. Maybe while I'm doing it, I can show the results from the launch last week and we can compare them just for fun. So this is a result. Oh yeah, I can see. So look, learning from others, sharing ideas, working in a team. So the people here today have got learning from others is top, like it was last week, but accessing real data, writing a collaborative paper is also important. That's good. By the way, for the most recent challenge, for the RTDT challenge, we submitted a paper to Wind Energy Science, and it's currently in discussion. But yeah, it's possible quite easy to do that from a WeDoWind challenge. Anyone else? Is anyone else still answering? Wants a bit more time or not? Okay. And I'll move to the second question of 2. Make sure I go to the right one. This one. So you now should be able to see. I will take part in the new challenge. Probably not. Hopefully people who are spending time listening to us speaking are not going to click on probably not. But maybe. It's anonymous, so we won't know who you are. So 4, 5, probably 1, probably not. I bet that probably not was Christian.
Me?
Very anonymous, yes.
Johnson.
Because I will take part, not as a submitting.
Johnson, I meant. Anyway, okay, so that's good. So 6 people have put probably, and 1 person has put probably not. So that's a good start. We'd be very happy if we had 6 participants. We also have, I think, 2 signed up who are not here today. So that's it. So now it's time for any questions. But you can write in the chat or you can speak.
Hey, I have a question.
Yeah.
Where can I find the link for the Excel sheet where we have to submit our names and information?
So in the chat, I put quite a few links in the chat. So I put the registration chat. This page here I put in the chat.
Okay, perfect.
But I think if you're not logged into Google, you have to actually click on this link. Takes you to the external Google Doc.
Okay.
To access.
Yeah, got it. Thank you.
I'm able to do it in here actually, but for some reason I can't do it. Don't know why.
Excuse me, I have a question.
Yeah.
Models must be fully data-driven, or it's possible to use a hybrid approach like physics-informed autoencoders or something like that?
it is also possible to use this approach, but yeah, we cannot provide any additional information that you might need for a physics informed approach. Like, yeah, we cannot give out more detailed information about the turbines and stuff.
Okay, thank you.
Yep.
Any more?
Yeah.
Maybe one question. There was some answers who said they would like to work in a team. Do all have a team, or is here someone searching for a team?
So feel free to just speak and answer the question. Like if anyone's looking for a team, then you can say now. Is anyone looking for a team?
So if it is the case later, or maybe then just write in the discussion part. I think that's the best way to find someone.
So the idea is that if you write yes here, so for example, Isha, who's not here today, but who I know, wrote yes, which means she is looking for someone. I think Tullio, you didn't write anything, but
no, yes, I'm not looking for a team to be. I can work alone.
Yeah, so if I think either you just write in the chat in the feed if you're looking for someone, but otherwise you can look in this table, right, and you see, okay, Isha's looking for someone. You can contact her. Like the best way to contact people is to just go on WeDoWind to this private chat and just write, and you've got her name, so you can write a message. Or the other way to do it is just in the challenge discussion. You can write a comment, or you can also just write a comment in this challenge registration bit here. You just have to be aware about making comments on WeDoWind. If you make a comment in the comment section, people are only going to get notified if you tag them. So if you just write a comment here saying anyone looking for a team, probably nobody's going to read it. So if you see, for example, Isha is looking for a team, it's best to write here, hi, Isha, and then you can tag her. I'm looking for a team, and then you write that there. I actually think it's better to do that than to write a private message, because then people can join in the discussion. But if you write in the feed, so the idea is that if you have a space, some spaces have multiple challenges in them, right? This space has only got one challenge, but we have other spaces where we have more than one challenge. So the idea would be that in this thing called challenge discussion, that's where the things related to this challenge get discussed. But we also have a feed where anything for the whole space can be discussed. But at the end of the day, if we only have one challenge, then it doesn't matter where you write it. But the thing is, if you write a feed and you press post, you get a question saying, do you want to notify people? And if you notify people, they'll get a notification. So it's actually best, if you want people's attention, to write in the feed or tag them. It's clear? Any more questions? Okay, so if you want to take part, just sign up. If you start doing some work and you want to discuss it, then write either in this discussion or in the feed. We try to encourage communicating openly, because then we learn from each other. Then the next event will be on whenever Kristin said it was, the 3rd of November, where you can just come and ask any questions, or you can, if you've got a few plots to show, you can present what you've done. Just from previous experience, it's quite useful to have these meetings. So in previous Kaggle challenges, we've actually asked the people who are have got good scores on the leaderboard to present what they've done, and then there's been some brainstorming and some discussion about how to improve the scores. And as Christian said, it was quite a challenging challenge. I think it would be very useful for you to all come to the meeting and actually talk to each other about what you've done and try to learn from each other. So it's not really a competition in the sense you're trying to beat everyone else and you're trying to win a prize to have the best solution, but it's more like trying to learn from each other and get ideas and share in order to get a better solution. So I'd like to encourage collaborative and participatory behavior. That's it. And get in touch on the WeDoWind platform with me or with Christian or Florian if you've got anything else you want to ask or talk about. Yeah, then I guess Christian, if you send me a link to the recording, or you've got it, I'll put it online and I'll send a message telling everyone that it's available.
Yeah, and I actually ended now the recording. So yeah, sorry, I did not end it for the question discussion.
Okay.
Forgot it.